Good afternoon or good evening, everybody. Welcome to day 2 of Intro to Coding Live. Um, we're going to go over just a reminder on how to get back into code spaces for everybody. And I'm going to go over making sure you know how to shut code spaces off just in case, because I do remember that we may have missed that yesterday. So I'm going to share my screen now. Can everybody see that?
I can.
All right, good to go. So if you're not inside code spaces, one second. Just a quick reminder you click the hamburger menu next to the Octocat right up here. You select code spaces right here, and that will take you to this page. And the next thing you're going to do is you're going to you're going to find your code space. You should have one. I had two in here to demonstrate. You should see the ellipsis over on the right. If it does not say active right here, this is important, only if it doesn't say active right here. I want you to click the ellipsis and open in browser, and that will fire up a new browser and it'll start loading everything for you. While that's loading, make sure you keep the code spaces tab up, because when we come in here to be able to shut it down, and you want to try to remember to shut this down after class or when you're done going through the lesson content and whatnot each day, if you go back to the ellipsis, and there will be a stop code spaces option. As soon as it populates, I'll be able to, there we go. So you hit the ellipsis right next to your active status, and you want to stop code spaces. This is what we need to do at the end of every class so that you save your time and everything. All right. If you have any pop-ups popping up down in the lower right, go ahead and close those out. We will be under lessons, and we're going to be at number 2. So what we should have, I'm going to close this practice out. We should be on Python conditional statements, truthy, falsy, logic, and functions. Okay. So we did see a little bit of these things earlier, but we didn't really dive too deep into them. Um, we remember a little review on the Boolean values, Boolean expressions. They they always result in one of two values, true or false. So it's your true, false, on, off, yes, no, any of those sort of situations. And this is just an example. And double check, make sure you have Python reading up here. If you don't, you should be able to click the select kernel, and it should drop down with the kernel that you used with lesson 1 on Monday. So if we execute this, we'll see that the type, we're looking at this true value, and when we want to see the type of it is a class bool, and bool is short for Boolean. Any questions there? All right. Just like, so Booleans are another type of variable. As we talked about yesterday, it's a data type. It can be assigned the true or the false value. So this prints false. And if we change this to true, excuse me, somebody have a question?
No, I just coughed.
Oh, I apologize.
Sorry.
All right. And then that's our two different values for our Booleans, true and false. And keep in mind that this is capitalized. This is, if you try entering it in as a lowercase, you'll see inside code spaces to give you a nice handy little yellow squiggly, and it gives you this error that false is not defined. If you try running it, what it's thinking, the reason why this happens is it thinks that false is a different variable name. So this is very important to be capitalized as false. Depending on the code editor or IDE you're using, as you can see, this one is colored in blue and this one's colored in white. And if you notice, the variable, the Boolean, is in white, so that's another indicator that it thinks that this the text false here is for a variable, not the actual false value. We've dealt with comparison are there any questions on any of that before I go forward? All right. I'm pretty sure that all of us have experienced comparison operators before. Now, we did talk a little bit about the double equal signs for equal to. That one's a little bit different from math because you're usually used to the single equal sign, but in programming, the single equal sign is for assignment. Now, the exclamation point equal sign, that relates to not equal to, so naturally the opposite of equal to. We have the greater than, less than signs, and to do greater than or less than, because you can't draw a line underneath the key very easily, it's a greater than plus the equal sign for greater than or equal to, and the less than plus the equal sign for less than or equal to. So, any questions there?
Nope.
All right. So here, this is an equality expression where we're using the double equal sign, where it says print 23 double equals 32. We're basically, we want to know if 23 is 32. Now, naturally it's not, so we get the Boolean result false. Now we could take those expressions and we can wrap them inside a variable, and that's what we're doing here in the next section. With Boolean 1 equals 450 is less than 350. And then we have the print statement to print output that the result, which that's false, so that's where we get that from. If we switch it, we switch the direction of the sign, now we have true, and it's pretty fairly straightforward. You can also do your comparison operations using variables, which is usually going to be the most, this is usually the way you're going to use your comparison operators. You're going to be checking one variable versus another variable or a constant or something like that. And just like with the rest, num1 is 8, num2 is 6, 6 is greater than 8, so this evaluates to true. Any questions there?
Nope.
Now, we have membership operators for membership checks. And what we're doing is we're checking to see if a particular value is inside a collection, like a Python list or a string or something like that. Because remember, a string is a list of characters. So we have the two operators in and not in. So here we have this big long list of values that just stretches outside of the initial viewing area. And then we're looking to see if the value 2017 or 2017 is in STL, St. Louis blizzard years. So if we run that, it's false because it doesn't exist inside this set. We could go try searching for it, 2017, and we have 2015, 2018, 2019. These are deliberately put in order to make it easier to see that. But if we decided we wanted to put 1883 in here instead and run it, we'll see that it evaluates to true. It's one of the quick ways to search through stuff. Any questions?
Nope.
And the same is true with not in. So if we go, because 2017 is not in there, if we add not in, this will evaluate as true. Now we have logical operators. They do kind of relate, they do work with, these are math concepts. And this is where you could start building complicated conditional statements that are, yeah, complicated Boolean statements that are trying to check for multiple things. So like this first expression, it says the print is always here for the output. So this is the proper way that you do this. But what we're printing is we want the result of is 10 greater than 8 and is 23 less than 25. So it's got to check both of these. So the way and works is both the left and the right side have to be true for it to be true. So we'll run that, and now we have true. With an or, it would have to be one or the other or both, and that would evaluate as true. So if either of the sides are true, it is true. Now you also have the logical operator not. So if I went and we see how this prints true, if I go through and add not, and I'm adding parentheses the same way we deal with PEMDAS with math to lump everything inside the parentheses so it evaluates that first and then does what's on the outside. But now when I run that, it reverses it to false. Any questions there?
No.
You can also do that individually per expression. You could go not. So if I wanted to negate whatever was coming out of here, it would still come out as false. Generally, you just flip the direction of the sign, or you could do other logical ways, but it's just one of the ways that logical operators work. All right. We can combine our logical operators with our membership operators. So this first piece, the first piece, what we're doing is we're evaluating everything up to the or. So we want to know if 9 is in this list of numbers, 2, 3, 4, 5, or W, the character W, is in 123.45 W. That evaluates as true because W is in the string here, but 9 is not in the list. And then here's the example of not, where 4 is not equal to 5. If we take out the not, you'll see this evaluates to true. And then by adding not back in, we are reversing or negating whatever the result of what we're checking inside the parentheses are.
Would using not be considered not best practice?
It depends. So Here's one of those places. Do you remember the none type we talked about yesterday?
Yes.
So this would be a use case for the none type. So
Oh,
we want to check if a variable is not a none type, which means it has some sort of value.
okay.
Even if it's an empty string, remember an empty string is not the same as a none type, but if a variable's never been declared before, it doesn't have a type. Does that help?
Yes, yes, it does. Thank you.
All right, great question. Thanks. All right. Any other questions?
No.
All right. Okay, this is a very important thing to remember when you're dealing with logical expressions. You have to make sure that you have a complete expression on both sides of the expression, whether it is and an or. All right, because not goes on the outside and an or go between. So here is an example. And in English, this reads fine. We would read this as is 2014 and 2018 in St. Louis blizzard years. However, 2014 is not in here, but it evaluates as true because
Oh, bad.
2014 is a value. And that's all this is saying on the left side of the and is 2014 a value and is 2018 in St. Louis blizzard years. So if I change that to go what we intended, St. Now we get the expected result of false because 2014 is not in the St. Louis blizzard years. So this is where it can get a little bit, you have to
Yeah.
be deliberate. This is where it can get a little bit confusing because it reads perfectly fine in plain English, but we also have to remember a computer doesn't speak plain English. Any questions? Excuse me, any questions there?
True.
Okay. Yep, then this is just what I typed in up top here. So you'll see that it evaluates as true because 2014 is a value, but when we complete the full expression, it evaluates as false. All right. Any questions so far? How fast am I going? If I need to slow down, go ahead and let me know.
No, it's okay. I mean, I got it on that last part. It is going to be a little confusing the way it reads in English, and you got to really look at it.
It takes getting used to. One of my favorite things to do is to add parentheses. So add parentheses around your statements, and it helps make it make sense. And this helps me a lot. So if I go ahead and I add parentheses around this, now it doesn't make sense to me. Does that help?
Yeah, well, it does a little bit because you're breaking it apart, and how
That's the key.
the
Yep.
computer is going to do it.
Simplify the problem, break it down to the pieces, focus on, treat these ands and ors as like a hard separator. You got to make sure you finish thinking, you make sure you complete the first one and then you complete the second one.
Like an incomplete sentence.
Yes.
That's a good
Also,
tip. Thank you.
the parentheses don't affect it, right? It's just our
Nope.
way of just making sure that we can visually understand, hey, I'm separating these terms.
Yes, that
Okay.
parentheses help both parentheses to end up being making it more readable for somebody else coming in to see what you're looking at because someone who might be skimming through fast or whatnot might just have gone over the like somebody reviewing your code or something might have skipped over this upper example thinking that was okay and just kept going through. And because you're going to get a result, it's not going to give you an error. And this is where it's not going to give you a syntax error. Instead, this is what we call a logic error because there's nothing wrong with the actual structure of the program, but it's not giving you the result you expected.
Thinking on it.
Hmm. Any more questions before we move on?
No, sir.
Okay, we did briefly touch on if statements. Um, does anybody remember anything? I know, does anybody remember what we talked about yesterday? I know it was pretty quick and everything.
Yeah, we talked about yeah, we talked about this in the LF. I think we got into else a bit. Yeah.
Yeah. So as to say, if whatever statement is true, then I don't know, if one is less than two, it equals true, else false. Like if it says the opposite, right? Or something like that.
Yeah, that's basically the outsides of our statements, but where we start stepping into this is what we start defining what we want the computer to do if that's true, and then what we want it to do if it's not true. Okay. So yes, you've got the concept. So yes, you guys did great there. And now we're going to step into a little bit more. Is these conditional statements are used all over programming languages. This is another one of those cornerstones of your building blocks.
Is this
So
kind of
walk,
like the
go ahead.
example of the thermostat, like the on and off? It's almost like a switch. This conditional statements like a universal switch. If, below 69, turn on. It else turn on. You know, that's what it feels
Yes,
like. Like just like a light switch, right? These if and else.
that's what the if else is. Yes, that's a light switch. You're going to do
Yeah,
one or the other. Go ahead, Todd.
I s- yeah, so I was just going to say I saw else as the easiest one is everything else and it falls into into this basket.
Yep.
Um and if and elif kind of divide what's left, but else is like your everything basket. Everything goes
Yep.
in there that's not does not meet the conditions above. That's I like else. It's easy.
Yeah, we're gonna jump down and we're gonna cover LF a little bit. Simoy, this is not looping, this is conditionals. We will cover looping later in the course, but looping is yet another very important concept. So with this, um, we initially set the temperature at 70 and we check if it's less than 32 and we have a message to print out. And just like Todd was saying, for everything else, we're going to do this other thing. Now, we don't always need an else. Okay. So if I go through and if you guys remember, the pound signs are comments. If I go through and take out the else, that changes it to I only want you to do something if this is true. If it's not, I want you to do nothing. I want you to continue on with the program. Any questions with that?
No.
And one key piece to remember, always pay attention to these colons. So the
Yeah.
else is pretty easy. It gets the colon right after, but you make sure that you get the colon after your if statement. So your if statement ends up being this piece of the temperature. And remember, this is a Boolean expression. It's gonna evaluate to true or false. put your colon in, and then we have our indentation, just like we were covering yesterday. Our else drops back out because that's the next piece of logic. And then what we're going to do there. So when we run it, it actually executes the else, and pretty much what we had covered. Now, the elif, I think, was it Todd or who was it mentioned the elif?
I did, I think.
Okay.
Yeah.
So elif is basically, it stands for else if. You can think that the two words just got pushed together and they used elif. So that's what this is. So you want to add in more conditions. You want to check more things. And this is where you can start getting your if statements into something complicated. Especially when you want multiple different values depending on, in this case with the temperature, how cold is it or how warm is it? We're going to send a different message. Another key thing to note here is you can nest the if. So what nesting means is we're putting it inside. So we have our first if statement, if the temperature is less than 32, and then we have another if statement inside that, that is if the temperature is less than 10. So the first expression evaluates to true. Then we check the next if statement, and if the temperature is also less than 10, we're going to print it's dangerously cold outside, and then we're going to drop back to the outside logic, and we're going to print it is literally freezing outside. Stay inside with jammies and hot cocoa. And we have the elif. So if the outside evaluates to false, it ignores everything inside and then checks this elif, where temperature is less than 55, print layer up and stay warm, and for everything else, looks like it's going to be a nice day. So what I can do is I'll run this with a temperature 50 at 70, and we have looks to be a nice day. So if we drop the temperature below 55, we'll put it at 53. And now we have the layer up and stay warm. So we're inside this block now. Now, if we want to get the temperature below 32 so that we can get, if we put the temperature at 30, we'll see that it only executes this statement because the nested if ended out false. And just like I was showing you before, if you don't need the else in there, it's going to print this anyway. And if we drop the temperature to 9, we get both of our messages. Any questions there? I know that's a couple different concepts right there.
Yeah, the nested if is new. It wasn't in the modules, but I can see how it could be valuable because it kind of sub compartmentalize the first if. I can see it'd be useful.
Yeah, so sometimes there's more processing in here. So you might do, well, yeah, actually, here we go. What I'm doing is I'm changing the temperature. So now what happens is we go into the top if statement, we entered the 32 condition. Okay. Now I changed the temperature, and because even though we started out at 9, I changed it to 30. This is now false, so we skip it. We run through this logic and continue. This kind of technique right here helps with trying to map out your thinking to make sure that you're going through the blocks you expect it to. So usually they're kind of, we call it print debugging, and you can put little messages in there to help check the flow of the program that you're trying to write. And this is a good spot to make sure it's hitting the if statements that you want it to hit. So if I take that back out, we get back to our initial example. I know that was even a little bit more in there. Any questions about any of that?
Is it possible to nest inside elif statements?
Yes, it is. You can also nest inside the else, because
Oh.
it's there. Let me. Oh, I'm trying to get the right. These pieces I'm underlining is all part of the same statement. Okay, that's all part of the same conditional. And the nesting, there could be lots of logic in here. There could be doing a bunch of math and doing a whole bunch of other stuff. Like maybe they want to convert the temperature to Celsius or something like that. And then, check other things or whatnot. It all depends on what you're looking to do. But that's the basic idea on being able to utilize if statements, if, elif, and else statements. And it really starts branching out your program so that you can have it doing different things. It's one of the small pieces of programming, but it's a very powerful piece.
I also noticed there's special indentations that are key that you have to have, otherwise it won't work.
Yes, if I remove this indentation and put it here, you see how it just gave me a red squiggly?
Yes.
It's because I started a block here, and notice how I hit enter and it automatically indented because
Exactly.
it expects something. So if I put that in there, now it's fine. But now it's also printing the other statement, which wasn't what we intended. So yes, that's another place where you want to really pay attention to your indentation, because if I wanted to print if I wanted to print something else as part of that, so I got it's too cold to snow, but if I accidentally got my indentation wrong, oh, let's change this to 30. If I get my indentation wrong, then it's executing out of the logic where I expected it to. So yes, that's a good point about making sure you pay attention to all of your indentation. Any questions here? Excuse me. Here's another example of the elif for the logic trees. Yeah, you have the nested ifs or logic tree. This is your simple if, elif, else, and there's really no limit to how many elifs you put into there. But when you start getting a lot in there, sometimes it's a good idea to stop and really look at what you're checking for to see if it's really necessary to have a lot of them. But that's more for like reviewing your code. The primary goal the first time through is to get it to work. So if you ended up using 10 elif statements to get the logic to work the way that you wanted it to, and then you found a way to start combining conditions, or you realized that you could have checked for a range or some other concepts, you could go through and start. It's a process called refactoring, where you start making your code a little bit easier to read. Because I can imagine if we've got 10 of these elif statements and an if and an else, that starts to get into a big pile of stuff that you gotta kind of pick through, and it can get a little bit difficult to read, especially when you're not used to it. Any questions?
Yeah, I have a question,
Go
DJ.
ahead. Sure.
Um, when you write multiple if statements, elif statements, when if there's like two true if statements, let's say the very first one is true and then like the second from the bottom is true, what prints? Like does it print in sequential order?
First in. That's it. It stops at the first one that's true, does its thing, and jumps out of the loop. Or it
Got it.
jumps, it's sorry, I used the wrong term there. It's not a loop. It's one statement. Okay, so this is one block. So once it evaluates this is true, it ignores the rest. That's where figuring out where you want your if statements checking, because if you had five checks, but the first and the third were true, then one question we should look at is why is the third true, and does that actually belong in that spot because of the order that it's going through stuff? Does that help? That might get a little confusing until you actually see it. Okay. Now, Janae, you're asking if why didn't it also print the elif command since the temp is also less than 32? Um, oh, okay. I apologize. Okay, so that was already answered. Thank you. And one of the key things to think about is when you're going through the if statements, the conditionals, it can start to get confusing. And to be honest, sometimes it's just easy to have a scratch sheet of paper and just kind of scratch it out just to kind of check that your logic's flowing right. Any questions there? I'm going to check
No.
this next session. Okay. Oh, this is exactly what we were just talking about. Okay. Um, this first section evaluates to true because negative 60 is less than 55. But our next check is if our temperature is less than 32. This is where I was talking about it. You've got to pay attention to the order that you're putting these in. So if we're checking, if we want this to be our coldest statement, it is literally freezing outside, stay inside with jammies and hot cocoa. If we want that to be our coldest statement, we need to pick which order we want to go in. So this is where you make the decision of what makes sense to you the most. Should I check for the smallest value first, or should I check for the biggest value first? So if we wanted to, what I would do is if this is my statement I want for the coldest value, we need to move this if temperature is less than 32 above if it's less than 55, because we're at negative 60 and our intention is getting this statement to get printed. But when we ran it, we got the first statement because that's the first one that was true and it exited right out.
Okay. Yeah, I see the logic there. You gotta, yeah. I was like, what difference is going to make? But I see if you want to get down to negative 60 or close to it, you got to put it first. Otherwise, it's going to hit 55, and that doesn't help you.
Correct.
Yeah. I see the order is big. I understand that now. Wow.
Yeah, and this is where that little concept of print debugging helps, where, um in this particular instance, if we're trying to figure out why it's going wrong, we go print something simple like temp is less than 55. And then we print temp is less than 32. And we start using those because a lot of times this variable might not be assigned right here, or as somebody mentioned yesterday about like input functions and stuff. And then we get our little debug statement here. Simon, I see if you're saying if you nest the elif or turn it into an if, it also works. So you're talking about if you turn this into an if? Okay. So what we now have, I'm going to clarify this. We now have two different blocks. As soon as you change this to an if, it starts a new block. So yes, it does work because we're performing a different check. However, we're also getting the layer up and stay warm message. And if that's not what we wanted, then breaking it into two wouldn't be, it would get the message to print, but we have a little bit more to work on if we don't want this layer up and stay warm message to print. The quick solution I see is reversing the numbers, reversing the logic and the numbers.
The order.
Yeah, reversing the order of these two. And what kind of gives that idea to me from the design is because this else says it looks to be a nice day. So it kind of gives us the idea maybe we should be checking for the coldest temperature first because the rest of our logic works that way. Any questions there?
No, I see what you're after. You got to check the logic. Yeah, maybe going with the coldest temperature first, because I just automatically assume go with the hottest, but there may be cases where you got to go with the coldest
Well,
first. It depends
if
on what you're
if you
looking for.
go, it does. And if you start with the hottest, then you might want to check to see if the temperature is greater than and switch the direction of your sign and change your logic. That's why for me, it's handy to just kind of stop, check myself on paper and look at it and say, does this make sense? Honestly, sometimes getting away from the screen helps these things just click because well, I'm gonna show you if you can see it. This is my rubber duck. And what that's for is called rubber duck debugging. So if I'm having problems mapping out some logic, one strategy is to talk about it. And you don't always have somebody to talk to. So what rubber duck debugging is you could take a rubber duck and explain the problem, explain your logic to the duck, and you're listening to yourself as you're talking about it. And if it doesn't make sense, you know your logic's wrong. I know it's funny, but it works.
No, but I see the importance of the order because with the negative 60, it'll jump down too quick,
Yeah,
and you don't
because
want that.
the first one evaluates as true.
Yeah.
So we skip the rest. And it is a common pitfall, especially when you're learning how the structure works. So that's all what a lot of this block's about. And it is confusing stuff. I do get that. So I appreciate the feedback because it helps to talk through what you're thinking about and ask the questions of, well, this looks like it should make sense. And that's the problem with a logic error is you wrote it that way because it made sense at first. And logic errors are probably some of the hardest ones to locate inside code because you have to really start digging into it. You really have to read the stuff. Remember what I was talking about yesterday, that a lot of software engineers, a lot of programmers spend more time reading code than they do writing it. Okay. And we already talked about this, how we would fix it to be able to get the intended results so that we got the freezing. We reverse the two blocks. So this section becomes an if, and this section becomes the elif. Does anybody disagree with that? Does anybody have a different way to make that work? Because there's more than one way to make this work.
Personally, I just kind of did what you said initially, just reversing the roles. Mine's
Hmm.
reading in the student example, I typed it in as if temperature is less than 32, and then it's the first message, it is literally freezing. And then my LF is just the 55 with the layer up and stay warm. And that logic, when I press play, it gave me the right or the intended outcome, the
Yeah,
logical and
right. The other way you could do it is checking for the hottest temperature, but you got to change your directions of your signs. You're changing all your messages. It does require more work, but in the end, you can still get it to come out with the same result. So I apologize if I get your name wrong, but Darwis is asking, can't you just subcategorize and compartmentalize it again, like the example above? I believe what you're talking about is the nested if example, correct? Okay. So if you wanted to do that, you have to be careful because if we don't want this, you can nest the if, but if you don't want this message to print, then we would have to take and put this inside the else to this. You want to see that? So if we take this, we're going to drop it down here. So what you're talking about is we nest the if. So if we go and we move this here, and we change this to an if. Now, if we go this route, it's going to print both messages. All right. But if our intention is to have one or the other, an alternate method would be to do this. Like I said, there are multiple ways to come to the same conclusion. Anybody have any questions with that?
No, I would just say I would stick with the original. I think it's the easiest way to go, but that's
It
just me, I guess.
it depends on your preference because both of them work. And I mean, that's goal number one is get the program to work, right?
Yes.
All right. So before we dive into functions, what I'm going to do is we're going to go ahead and take a 10-minute break. I have 6:47. Oh, 1 second. Simon also has a method here. I'm going to copy your method right into here so everybody can see it and we've got it for reference for video. Is that okay, Simon?
Yeah.
All right. So does everybody see what he's done here?
Yep.
Okay.
And
Uh,
he used an and. Yeah, that's
Yeah,
cool.
he added an and to it. See, and there is yet another option. There are other ways to check for these numbers and stuff. So like, um, there's a lot of other stuff. Well, I believe we should cover them in, I believe, the collections later along the course and whatnot to show you other ways of being able to check for some of these numeric things. But yeah, thanks. That was another great example.
That's really good. It's really short. That's even better. Not to,
I
disrespect the
think it depends.
instructor.
No,
Yeah.
no, no. This a lot of this stuff comes down to preference. It really does. So if it reads easier to you that way, then by all means do it. Because if you have to come back to this a week, 2 weeks, a month, 2 months, a year, it's got to make sense to you then too, doesn't it?
Now, DJ, you mentioned that, we could use a print statement in order for debugging and checking to see if
Hmm.
all this is right. You use the word debugging. Me being an English major, former English major, I'd say that's a case of editing, is what you're doing right there, using the print. Would that be a good
Actually,
analogy?
well, it's actually there's a reason why it's called debugging, and it actually goes into the history of computers. So I believe it was back in the 50s. There was 50s or 60s, I believe it was. And you remember, I think people might have known that they had the large computers that filled up rooms and stuff, did the card punching and that sort of thing. There was a lot more moving pieces and whatnot. And there was, I don't remember when I was reading about it, I don't remember what the specific issue was, but there was a malfunction going on with the program and everything. And they started inspecting the hardware, and there was literally a bug. I think it was a moth caught inside the machine and causing problems. And that's where the nickname or the name debugging originates from, according to most of your computer science texts and stuff. So there's your
Oh,
useless information for the day.
okay. Like I said, as an former English major, I just called it editing, but I guess I see your
Yeah.
logic there.
And with software engineering and stuff, you're going to see when you're talking about programming, debugging is universally understood. Editing might come into play on specific stuff, or there's editing software and stuff. You see how that can start getting nuanced.
Okay, so I need to kind of keep those two things separate, editing and debugging.
Yes. Yeah.
Okay.
But,
Okay, so it's
uh,
not a good analogy. Okay. Okay.
well, the idea behind it is very similar. The idea behind it is you're putting the idea together, but sometimes the terminology is important. Well, most times the terminology is important inside software engineering. There's places that words that two different terms look like they could be interchangeable, but they mean two different things and that sort of thing. And we'll
Okay.
see that with functions. Um, but I'm going to put you guys on break. So I have 6:51 right now. What we'll do is we'll be back 7:01. That's Central Time. And I'm going to pause the recording. All right. So welcome back from break. The next piece we're going to go into is Python functions. And Python functions is another major building block. It's a major thing we need to understand when programming, excuse me, not just Python, but any programming language. And one nice thing about the text here that explains how functions work is across your browser, all of these buttons, everything here is associated with a function. So, in a nutshell, functions do things. These are the small pieces, these are the pieces of the program that do things. So, like if I click my home button up here on my browser, there's a function in there that gets whatever URL my browser set to for home and sends the browser there. Any questions with that?
Nope.
Okay, so we talked about built-in methods with strings yesterday, and this is what this example is for right here, the capitalize method from strings, if everybody remembers that. And what it does is it capitalizes the first letter of the string that we give it, and then we have the print statement to be able to output it. Now this print, this is a function. That's what tells the computer that I want you to output this variable name. So functions, and this is where I was kind of starting to hint towards Todd, but this is one of those spots where terminology really matters. And it has to do with functions. Functions can take inputs called parameters. Okay. And when you define the function, I'm kind of skipping a little bit. This is the def. Def is short for define, and this is how we create a function. So this is where the stuff looks the same, but the terminology is different. So in this example, we're using the keyword def for define, and this is a name we make up, just like with a variable name. So we need to ensure we're not using a Python keyword when we're creating it. We're using the snake case like we talked about yesterday. So our function is called total sum. We open up these parentheses and we supply that we want two parameters, num1 and num2. So if we go back up here and we look at our print, all right, you see that it takes something in. But when we're calling print, when we're calling the function, that's when it's called an argument. So we're calling the total sum function here after we've defined it. Num1 and num2 are parameters, and as you highlight over it, you can even see that the code editor is telling you that it's a parameter. It doesn't tell you that these are arguments here, but that kind of, do you see where that kind of tells you where the intent of what you're using it for?
Yeah.
And to be honest, I mess it up sometimes. I reverse them and whatnot, and I try to do better. So it's something that's always going to be one of those things. It can be something that takes a while to get used to.
Well, what would you use define for, though? What would be the practical use of it?
Define is to create a function. So what we're doing right here, what I was explaining was just the pieces of the function. So we have our parameters, right? We have the DEF for define, total sum. We want two parameters. And if you notice right here, just like with the if block, we have a colon and we're indented here. So inside this block is what the function does. So what we do is we're taking num1, which is right here, and num2, we're adding them together, and we're assigning them to the variable sum. And then we're printing out our variable sum. So if I run this, now let me comment this one out so that you can see it running first before we go into the type error. So you see how this, if you comment out, if you're following along, go ahead and comment out the second total sum and then run the block, and you should get 5 because num1 is 2, num2 is 3, and then when we follow through the logic of the function, 2 plus 3 is 5, and then we print out 5. Any questions there?
No.
Okay. So this is where we use define. It's to break our logic into smaller pieces because just like we were talking about with the logic statements, you want to break it into the simplest pieces or the most reusable pieces to be able to make it so you're not repeating. Like if we were doing this particular sum multiple times or something with a lot more complicated logic, like a password checker or something like that, and we're doing it for every login, you don't want to have to type that each time. So we build a function and then we could just use our function name instead of retyping the code. You see the usability there?
Yes.
Okay. Now I'm going to uncomment this and now I'm going to run it again. And we have a type error. Can anybody see what the issue with this is?
Yes, you didn't put the 3 in there. The
No.
the other parameter. You didn't give it another parameter.
This time is the argument. This time is when we call it the argument. But yes, you are correct. It doesn't have to be the 3. We could put whatever number we want, and that's the reason why we created the function. But yes, that's the key there is we know that we've done it wrong, and pretty much the error is nice and easy. It tells,
You're missing a number.
yeah, that's really what it is. But to get the same result, that was exactly correct. And I don't know who said that, but thank you very much. And we had the type error when we were doing stuff yesterday, trying to add incompatible types with like a string and an integer too. So that's kind of like working on a function when you're using that plus operator. Both sides need to be something that you can add or concatenate, and they both have to be compatible types. So that's why this kind of falls into that type error zone. Now, this technique, this kind of falls under best practice because generally when I'm writing my functions or methods, I want to try to return something. And the reason for that is up here, we're printing out the sum. And if we were reusing this total sum function many times, it would always print the sum out. But what if that's not what we wanted to do? What if we wanted to do something with that sum? So that's where this return comes in. And if you see in the colored text here, it's colored in red. So that means it's another keyword. It's not so we can't name any of our variables that. So if we run our code here, what's happening is we've defined our total sum. We've established that sum is num1 plus num2, and we're returning sum. So in this particular section, we're not outputting anything. How the code execution goes is it looks at the function, but it doesn't actually run anything. It just knows that this is a defined function. So when it gets down here and we see that we have a variable called sum, and we have a function which we're supplying 2 arguments, well, it knows that I have to do something because functions do something. So it stops, takes these arguments, supplies them into where the parameters are, and it does the calculation. It has the return. So now this whole thing becomes 5, sum equals 5, and then we output the sum. Now I know that was a lot. So if you need me to go through it again, if I went too fast, please let me know.
Just real quick, why would you need the return? You already had it with the print sum. I just think return is redundant, isn't it?
Not if we want to do let's see here. What if we want to go?
Okay.
Okay. Now I still just got
Yeah.
one output. I got one number.
You
And I
used it
believe
again.
that makes, yeah, I'm reusing the function.
Okay.
Okay. And I don't want to get a lot of output because if I wanted to print the sum here, if I added the print sum here, now you see how much I get there. It's
Yeah.
a mess. And it's generally cleaner that way. Now, when we're doing our print debugging, we would put print statements in there to make sure that our logic is going the right way and doing what we want to do. But as soon as we confirm that, we want to take those right back out, just like I did right here. Does that help make it more clear?
Yes.
And that is the key piece of functions is they're reusable. When you're building out a function, you're basically telling other people looking at your code, I intend to reuse this, or at least keep the logic together so that it's easy to tell. Is it's kind of easy. It kind of helps us out because we also picked a name called total sum, so it gives us an idea already of what we're trying to do here. And you could expand on this if you wanted to and add more parameters. And all we do is we just add more. Oh, and there's a logic error, you see. I added these in, but I didn't do anything with them. Everybody see that?
Yeah.
And that's
Okay.
why I
You need a
still got the
plus or a
5.
minus yeah, you
That's
still
right. You got to do something with it.
yeah, tell the computer what to do with the new numbers.
Right? You got to be explicit. And now we have our expected number. You see how quickly you can just modify that and expand it out. So it's one of the reasons why functions are pretty powerful. Now if I try to run this with the 2, we'll get that type error again because we changed the amount of parameters that we changed the amount of parameters that we expect. There we go. Now, this next section goes through and basically this is what happens if we don't use the return statement. Remember, we covered the none type, but can anybody take a guess at why it did it this way?
Sum plus print sum.
Doesn't have a function telling it what to do.
Yeah, because you don't
No,
have the return on there, and so it's not doing anything.
Yes,
but
It's incomplete.
it's incomplete. So this concept is called scope. Okay. For I know those of us that have been in the military, and I know many others, we've heard the concept of stay in your lane. Well, this sum only belongs in total sums lane. So it belongs right here. It means nothing else outside of it. It's kind of gray here if you can see. And when you highlight over it inside your code spaces, you'll see that it says sum is not accessed. What that means is you've assigned sum, but you're not using it anywhere. When you first look at it, you say, well, you could look and you might think, well, sum is right here. But because it's outside of this function block, it's not the same sum, even though it's spelled the same.
Is that
So,
because of the space? It's ignoring it. Is that why it's hitting the space and stopping?
well, this is the function.
Yeah.
And um just like it was said earlier, I apologize. My screen for seeing people's name is really small, so I apologize if I don't attribute credit to to people who came up with the suggestions and the answers and whatnot. But because the return wasn't used, yes, total sum added the numbers, but as soon as it left the function, it tossed it away because you didn't tell it to actually give it back. And that's what return does, is it says, I want this number back. In here, we said, do the math, and then I'm done. So by default, when you don't specify a return, a function will return none. Okay, that's that none type because it's not it's not defined. There was no value to it. There's nothing there. So if I go through and what I'll do is I'm going to change these to my sum. Okay. And we'll see that this still works. The reason why is my sum only exists inside this function. If I get out here and I want to print my sum, it's highlighted in yellow. If I run it, it's undefined because it's outside of the scope. It's outside of total sums lane.
So basically, when you use return, you're basically telling you're telling it that you're going to be using my sum in a different function.
Well, I want the value. I'm returning the value of what it is.
Yes. Okay.
So what I can do here is I can shorten this. I can go num1 plus num2, and it does the same thing.
Oh, okay. I see.
So my sum just because we're used to assigning the variables, it's a little bit easier to understand that. However, this is where it can get confusing because that variable only exists inside that function. So if we start using the same name, if we start using the same variable names, it starts adding possible confusion that you're accessing the same variable. Does that help?
Yes.
Scope can
Yes.
get tricky. So, but I think this is a good example right here where we didn't even need to use the variable at all. Because I could do the my sum, but if you notice how now you get the warning that it's not accessed, it's not used. Now, the difference between a warning and an error is an error stops your program from running. A warning tells you, hey, you could improve this. But sometimes, like in this case right here, with our function that doesn't return anything, it functions fine. It's not an error, but this is kind of an indication of, well, we assign the variable. Are we going to do anything with it? So there's a lot of times it's just little visual cues, but they can be really helpful when you're looking at them. Any questions there before I move on?
No.
Let's see here. So this is going through and creating your own capitalized method. So this is effectively doing the same thing that the capitalize method string method does, but we're going through and we're kind of breaking it down. Sometimes it's helpful to do stuff like this, so it kind of helps you understand what's happening underneath the hood. So inside this function, we're taking one parameter called target name, and we create this capitalized letter variable, and we want to take and everybody remember what this was before I go too far?
I change it to upper letters, uppercase.
What about this piece right here?
It'll be the first name in the list. Right?
That'll be the first character in your variable.
Yeah, whatever the list is,
Yeah.
the first thing, whatever.
Yeah, I apologize. We did cover lists. I do remember that. That's where it accesses the first element in a list. You are 100% correct. A string is a list of characters. And because I didn't point this out, we're sending it strings, but we're sending it strings, so we expect to deal with a string here. And that's where I needed to be a little bit more clear. So I apologize for that. So when we're talking about the string, yes, the first element, and just like you said, we're changing that to uppercase. So great there. Does anybody remember what this second piece does?
That's the start, I believe. So it'll start capitalizing from the first or the second letter
Yes.
or second space.
Yes, this is that splicing is what they call it. And your starts at the second letter. Do you remember what we said that this was called when we use the plus with strings?
Isn't that concatenating?
Yes.
Yeah, that was it. Yeah.
So we're taking the single letter, converting it to uppercase, and then concatenating it to, well, we've got the second letter. What does it mean when we put nothing after it?
It'll keep going until the last letter or the last space.
Yes. All right. Awesome. Thank you. Thank you for participating. All right. And as we see here, we just got the first letter. We know that we'd have to do a little bit more complicated stuff to get to the rest, to get the first letter in the second word. Now, does anybody remember how we would find that? This would be a method that we covered yesterday.
Repeat the question. What is it?
Do you remember how we would find the second word?
No.
I know we went through it pretty quickly. Do
Wouldn't
you
it be
remember
the start stop step thing?
That was it, but it's step is how you get there, the numbers.
the steps? I think what you're talking about is the splicing, right? There was a
Yeah.
different method that we would use to be able to get to this. Do you guys remember splitting? We did it with the date, and we split the date with the slashes to be able to break
Spaces.
the. Yeah.
Yeah. It
So
had
in this,
spaces in between.
so
yeah.
we'd split on the space, and then we would work with the next piece. It does deal with a different data structure that we haven't really covered much, but we will cover that concept later. All right, thank you. Here is a customized find method, and
Wait, so
go ahead.
you can assign that to the space, right? Because I was trying to figure out, like, obviously every name's spelled differently, so it's not like you can assign it to any one particular character. But if you do the space, it will automatically, regardless of the characters, look for that space and then capitalize that first letter of the first character of that.
This particular function will only do the first letter of the first word in the entire string. We would have to add more logic to splice, and we would I believe somebody mentioned looping earlier. We would also have to use a loop to go through and do the first letter of every word separated by spaces. I believe we will actually cover an example of that later in the course. It looks like possibly day 5 we'll go into something like that. But these are kind of the building blocks, because you're going to end up reusing these two pieces of logic for each word. So that sounds like a function, right?
Yep.
Yes.
Yeah, it's
Yes.
kind of
Yes.
like having a function inside a function. And that's where this can that's you can nest functions just like you can nest the ifs to build out all of the logic that you want to do. And a lot of time it's handy because you can simplify the small steps and break them out, so that as you're tracing down, if something as you're tracing down to see how it works, if there's something wrong with it, it starts getting easier to figure out where you're at and what are the things you're supposed to be doing. Any questions?
No.
Okay, so find was another method that we covered yesterday, and it locates the first occurrence of the word that we pass in and the string that we're looking, the string that we're searching. But if you remember how find worked, that returned a -1 if it didn't find it, or the index of where the first letter appeared. Okay, so this method goes through and changes that logic to return true or false. So basically, just if is it in there or isn't it? So as we walk into this function, we're asking, we want two parameters, both are strings. If we look down, oh no, yes, both are strings, but one of these strings is being reused. We have a long list right here, and we're supplying that in as our second argument up here, which is the parameter input data. Now, what we're doing here with this first line inside the function, we're setting present to false. So when we go into the function, it's a good idea, it's a best practice to give yourself your base case. So the base case here is we're assuming that the word is not in there. And then what we do is we create this name location variable, and we take our input data parameter, and then we're going to run the find function with the target name. Now, as we covered, that returns an integer of the index, or -1 if it is not there. So our check becomes pretty easy. If the name location is not -1, the name is in there. Otherwise, it's not. Now, the way you could, an alternate way you could do this, because looking at this, we're not using the present variable, and that's why, excuse me, that's why it's colored in gray in here. So an alternate way is we could go present equals true. And that's the only time we need to really touch it. So we return present. Any questions with that?
Why, exactly what is present? That's the first time I'm seeing that. What does it do?
It's a variable. It's just a placeholder for us.
Okay.
So in this particular instance, we're using it as a Boolean variable. And when we go into the function, we give it the value false. Okay. So that's our
Okay.
base case, is we're assuming that the word is not in the long string of data.
Okay.
And then we check the name location, we get our index, and if the index is not equal to 1, we set it to true. Now, why is it going to still work? Because I took out that else.
Yes, it'll still work because you're gonna have the
You don't need
negative one.
else.
Yeah, because if it's not in there, it's gonna return the negative one. So you don't need else.
Well, it's going to return the false because we're
I mean
returning
false.
present, right? Yeah. And
It's
that's where the present variable was assigned,
uh,
but we weren't using it.
and I guess present means its literal sense. Is that name, that
Yes.
word there, present or
Is
not?
the word present? Yeah.
It's literal. Is it present
Yeah.
or is it not? If it is, if it's not, it's false. I guess if it is, it's true. Would that be a good way of looking at it?
Yes. And was that Marianne that gave the answer, or who was that? Okay. This is what I basically did here was called excuse me, refactoring. And I prefer this kind of pattern because now instead of having two places where it's returning, I just have one place that it's returning, and it starts to, for me, this makes it easier to read because now I can trace all of the places where this gets modified. Does anybody disagree?
No.
And this is a preference. You don't have to do it this way. You could easily follow the other method and go with return true. Oops. Return false. Both of those work. So if we go oh, and then we get the same answer again. You see, again, there's multiple ways that we can accomplish the same stuff, and it does give you the ability to pick the way that makes the most sense to you. Any questions there?
Now, just to recap, the bottom line is we're looking for the names of these people in these big long lists, and you got the three
Yes.
names, and you're saying present, or not present, true or false, and it's giving you true, true, true. These three guys are there. True, true, true. That's the bottom line. Just getting there is different. Is that
Yes,
it?
exactly.
Okay.
Yeah, that's 100%. At the end of the day, we got the same result, but we just seen two different ways that you could do it. There's slight modifications, but I mean, feel free to experiment because this is how you learn.
One more thing, real quick. I noticed in New Year's, print find name, and then you got, that's obvious, Roger Delgado. But then you got this long string of data. Why is that? What is that, and why is it there?
So this long string of data is our second argument.
Okay.
Okay. And it's literally, a whole bunch of names in there. That's what it is. And this is just our test case. But like that could easily be a full text file. And you're
Okay.
looking for a name inside there. That could easily be that, or it could be a list of phone numbers.
Okay. But
You
you
know
have to
what I
put
mean?
that there, that long string of data. I just couldn't put, Bill Smith and, Frank Scott and Roger. I'd have
Well,
to
this
put,
is because we haven't explored the other ways, like the ways that you would load a file or have somebody type that stuff in and whatnot. This is the easiest way to get this is the most concise way to get the concept across. Okay.
okay.
Because in this particular case, you can look and you could see Bill Smith is in here, and you can look right up at that line and you could see that he's there. But if
Okay.
I change it to Bill Smitty,
You'll get a false. Yeah.
right. It's an easy thing you can play with and see how it works.
Okay.
And I highly encourage go in and change the stuff. Change it. Try. I mean, if you break it, figure out what happened.
Just to clarify, I mean, just for my understanding, that's just telling it where to look at, right? That long string of data, it's like, hey, refer to this data set and then give me the answer, whether or not it's there or whatever you're commanding it to do, right?
Yes. Yeah.
Okay.
So
Okay.
I mean,
Yeah, I got look here.
yeah, it's saying, look here. We could if we if we knew how to, we could have it like access a database and get the information from there. But fundamentally, the whole idea is the same. So if we had like a function to access the database or whatnot and get your long string of data from the database, you could just do long string of data equals that function and whatnot. Chris, I see you have your hand raised.
Yes. So I think I can follow everything in here. Like present is just a placeholder variable that is returned false unless there is something about the find name function that makes it define true. I can understand the name location variable because the dot find is a command within Python that can relate to your function.
Mhm.
What I'm having trouble with is the if name location does not equal -1.
Okay.
So I remember from Monday that there were two ways to talk about a list. You could either go 0, 1, 2, 3, 4, or you could start from -1 backwards. So the input for the name location. Oh, no, 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 never mind. I'm sorry. I'm sorry. Please, I'm talking too
No
much. So
worries.
yeah, what does
No
the
worries.
-1 mean?
What does the -1 mean? It is a return value.
Mm-hmm.
So that this find function
Mm-hmm.
returns if the word is present, it returns the index of the first letter. If it is not present, it returns -1. So
Gotcha.
the -1 in this case does not refer to an index. And this is also a best practice when you have a function that you want to return something like a failure state. -1 is usually that's kind of like it's kind of like a best practice again, where if there was something else inside here that would cause this function to fail, we could tell it to return -1. So then you could have some sort of error checking or something like that on the other end. Like maybe if the input data is not a string, we should return -1. So starting to check to make sure you actually gave us a string or that the function that whoever called the function actually gave us a string for input data and they didn't give us a Boolean value, which we can't use the find function on a Boolean value. Does that help?
Yes, it does. Thank you very much.
Um, but yeah, this is the first time we really kind of touched on the return stuff, but it kind of wraps right back into why and how these other string functions do what they do. And Yeah, the -1 is just a best practice. Sorry for reiterating the same thing. But and we did cover scope a bit. Any more questions about how this operates? I know there's a lot to it, and I know I just kind of modified it up a little bit, but okay. So we talked a little bit about function scope. This example dives into it a bit more. And let's see here. I think this right here will go through. Let's run this. Trying to remember. Okay, yes. This demonstration is a walkthrough of where the numbers are accessible inside the various pieces of scope. This is the global scope outside of all the functions. So your global scope is to the farthest to the left, no indentation. And so that means these variables up here are set. All of these are set as global variables. This does say random number, but it's not a random number. So it's just a number that we just kind of put in there. So please don't think that this is actually generating a random number. We defined our function. We've got our 3 parameters inside of our function. We've used the same name again, the random number. So is this going to conflict with that? Did we reassign that?
It won't, because the new random number will become 700.
It starts again. It's an indentation. So it kind of ignores the old one and goes with the new one. Is that correct?
Yes, that's the way I understand.
Yeah.
Yes,
It's indented.
they both exist, and that's why it's not it's actually a pretty bad practice to try to duplicate the names. So I think you saw when I modified the sum one, I put my sum in front of it. Sometimes it's easier to put just something to remind yourself that this belongs to number processor. It doesn't belong to anybody else. So yes, you're correct. We have 2 random numbers here, and we start modifying it. And as you track down through, as we get into the output, it starts showing you what it's doing. And if you look at the result, the global random number wasn't changed. So yes, 100% correct, you guys. This number never got changed because it wasn't changed outside of the function. It is going through a loop here. Oh, it has some other numbers that it's modifying, but the only piece that is returning is in the only place we actually get the results from inside the function is wherever we have called the number processor. So that number returning I'm looking for, or function returning, I'm looking for this piece right here. Right here. Need to add more spaces. So these were all supplied as arguments. It got 3 as a result of going through the conditional statements and pretty much, yeah, in a nutshell, this is demonstrating that in order to actually affect any of the values outside of our functions, we have to return them and then do our logic outside of the function itself. I know that was a bit in the weeds. Maybe I explained it better the first time. I don't know. What do you guys think?
No, better the first time. This is super confusing. I got to be honest. This one right here, what it's trying to do and what it's resulting for me anyway.
Yeah, I think this one definitely takes a little bit more to trace down through. Big it's easier to understand scope when you've got less going on. And this actually kind of helps demonstrate when variable names are getting used all over the place and they're the same variable names, it starts making it more difficult to track where your scope is, and start running into the potential to misunderstanding where your scope is and thinking you're dealing with number A when you're dealing with number Z or something like that. So I apologize for the
Yeah.
little
This
bit
one's rough.
convoluted piece. Yeah, this one is. I'll put a note to probably just change that. I mean, yeah, we already covered it pretty well, I think.
That just makes it a little bit more complex and confusing to me anyway.
I'm on the same boat.
So yeah, just remember, where did we go with the earlier one? The sum. Yes, the my sum right here. This right here really, I think this example really drives it home when we try to print my sum out here. We try to print my sum out here and it's not accessible. Or if we try to print sum in here. Now, this can pull it. Hold on, but this is, no. Okay. So
Did a
do you
none?
see?
Yeah,
Yes,
it did a none.
because sum is not assigned. Because we're
Yeah, it's my
evaluating,
sum, but there is no sum. It's looking for it, but it's
sum
not
is
there.
here,
It's
sum is
down. Yeah.
here, but we're in the process of giving it what sum is. So sum is nothing right now. And that's why we get a none. Does that help you guys? That actually,
That's better.
Yes.
Yeah, it confuses the computer the way it's printed here. That's why it's giving you a none. Would that be a good way of looking at it?
well, the variable's not defined yet.
Yeah.
So it's not an error. It's just we're in the process of defining this, because remember, we have to, we say we want a variable, and there's this function that we've got two arguments. Well, we need to figure out what the result of this is. So now we're going to go in and we're going to execute the function, but we're trying to call this before it is even assigned. So it's nothing. It
Yeah.
doesn't have a value yet because we just did it before the return statement. Does that help?
Yeah, a little bit.
Yeah, it does.
Yes.
Okay. Um, okay, we are at 8:52. Oh, I apologize, 7:52. I'm going to give you guys 10-minute break. And so we're going to be looking at coming back at 8:02. All right. Okay, so to expand upon scope, one of the pieces that they were demonstrating here was this random number. You can pull this value inside. So let's go up here and utilize the MySum. And what we'll do is put a temp num equals 20. We can print that number from inside here. So it can get it, all right? But it's tracking it in two different ways. So if we modify this, but we don't return it, then once we're outside, anything we've done to the temp num is discarded. I believe that was the piece that I was missing for explaining, and I think I'll go through and kind of iterate on that a little bit better. But that's the reason why this random number doesn't actually change down here, because it was never returned. And I believe we did cover that, but it was able to read it in. We didn't actually read it in. So I believe going through and showing you, like I did up here, that you can read that number in, change that number, but unless you return it, it doesn't go anywhere. All right, does that help clarify a little bit more? That was the piece that I was forgetting to explain.
I guess you're trying to tell us the importance of the return.
Yes.
Otherwise, without return, the computer's like, okay, where do I go? What do I do? But
No,
return tells it.
It just, yeah, it wouldn't. Okay, I did stuff with this. You apparently don't care, so I don't care. So it tosses it away and
But return says, no, bring it back here. We want to play with it or whatever.
yes, I need this. Yeah.
Okay. Yeah.
And this, we already kind of covered this. We've assigned the x equals 10. We've done something with it inside the function, but outside the function, it throws us an error because it's not defined outside of the function, because we did not return it. So it just reiterates a lot of the same stuff. And it can be a pitfall if you're working through a lot of the logic and you forget to return the value you really want. So this is a good familiarity piece. Typically, if you keep your functions pretty simple, it's easier to avoid forgetting to return values and stuff. You don't want it doing like 30 different tasks, because each task should be its own function. Does that help make it clear?
Yeah, a little bit.
Yeah. It's part of that keep it simple stuff. All right. So, yeah, we did talk about using the print statements inside the function. So this right here, if we run this block in when to use print statements, we get our intermediate result. These are the pieces that kind of helps us with our print debugging and whatnot, trying to figure out what's going on inside the function. Because if we're just focusing on returning stuff and we don't have the print function in there, it's going to do the thing, and we're going to check the complex calculation down here. We'll see it, the result, which this particular function returns the result, returns a result string, whether it meets or does not meet a threshold. And if we want to see what's actually going on, we can add the print statements in to make sure our logic is going on. You know, we kind of already talked about that. Are there any more questions around this? Okay. So here is an exercise. Where we can create a letter grade function. You guys want to help walk me through this? So what we can first do is,
You want to say
when we
define
want to,
or def, DEF?
yep, we start with the def. And what I'm going to do is I'm going to use that practice py file over here. So we can keep this right here. Now we do the def, and what we want this function to be called is letter grade, right?
Yes.
So what else do we need with this letter grade up here? Did anybody remember?
The parentheses.
We'll need a
Okay.
The
letter
brackets.
grade because
Hold on, where
of
you at?
string
Oh, okay. That's great. We have
underscore letter grade.
So what are we taking in here?
Taking in a
letter grade. 75 and 96 would be your parameters.
So that would be our number. We could call that number grade, right?
Okay.
yes.
Because we want a number to come in,
Yes.
right?
Okay. Yes.
So what I'm going to do is I'm going to throw, this is called a stub. I know I put this pass thing in here earlier. But that's called a stub. It's kind of like, okay, I want to build out this function, but I'm not putting any logic in it right now. So what we want to be able to do is we want to be able to print, right?
Yeah.
Letter grade 75. This is what you were looking for the 75, right? And then print letter grade 96. Okay, so this is now if we run this, we're not going to get an error. We got none because this does nothing. Okay?
Yeah. That
everybody-
makes sense. Yeah,
Okay.
that's you haven't lost me there. That I got.
All right. So how are we going to get this? How are we going to turn this numeric grade into a letter? Anybody going to help me out with this?
Would you turn that into a F or else?
Okay.
F 75
So
or
we've
F
got-
numeral grade is 75 returns to C, or it gives you the C.
number grade. What do I need to put here?
Greater than or less than?
Or just wouldn't
No,
it be just
exclamation.
equal to, or
Exclamation equals
Exclamation equals?
I
or
thought that was
greater than, less than.
Is
I
not
think it
equal
just
to
I think it's just equal
75
because
or 96.
I think it's just equal 75 or
Okay, do
because
we
I
want to
thought
Why
go
not? Why not?
which one? Okay,
let's just try
let's all
one
come
and
to
test it out.
yeah, which one? Let's try one. So what do we want to do the not equals? Do we want to do a greater than, or do we want to do an equals?
I like greater than because that's what I practiced on. Greater than 75 is a C.
Everybody want to do the
Let's
greater
try
than, or
let's try
you
it
want to
out.
do? So if the
Let's
numeric grade is greater than 75, right?
yeah.
And then we're going to this right here
And they bowed down.
is one of my favorite ways. Somebody's got some background going on. Could you please mute? Apologize. One of my favorite things when I know I have to use, when I want to return a result, is to just call that variable result. It kind of tells me what's going on as I'm planning through the process. So this is a practice that I like doing that helps make it easy for me to remember what's going on.
So that's a notation as result. I'm sorry. That's just a result. It's a notation then?
No, that's a variable name.
Yeah, I was gonna say that's a
Okay.
variable. Yeah.
Okay.
Yeah, so my variable's name is result. So what's that kind of tell you if you're reading through my code and I've got a stub right here? You could tell that it's not done, but what can you tell is going on?
That you want the result that's greater. I mean,
Greater than
less
75.
75.
So I should have result here, right? If we're greater than 75, what is our result?
See,
It's gonna be a
C.
C.
Greater than 75?
Or
No, if it's greater than 75,
it'll
It's
be
it'll
an
gonna
be
be
A.
more
A.
A. So
A.
it
There we
equals
go.
A.
Because it's gonna be 96. Yeah.
Less than 75 will be a C.
So what's the next piece we need? How do we
If
get the C?
if numeral
If
grade is
number
less
grade less
than
than
96,
no.
Do we need to do another if statement?
how about ELIF? ELIF.
Well, if we're just using these two pieces, we could go
Oh,
super, super simple.
Else.
There we go.
Hmm.
This is this is a little thing of this is a little thing sometimes. It's kind of like not over engineering it. We've only got two examples here. We could spend a lot of time and build a full grading structure if you really wanted to. But what are we testing?
A or C, 96 or 75. That's our bottom line, right?
Yep.
yeah, just two.
So now what do we need to do?
return or
Return.
yeah.
Just return or what?
Letter grade.
Uh,
Number grade.
yeah.
I need to return number grade?
Result.
Letter grade, because we're looking for letter
We're looking
grade
for the letter grade
Return result.
result. All
or
right. There
result.
you go. There's result.
Now, do you see why I use the term result?
Yeah.
Yep.
Like return some.
Yes.
It helps me remember it. And it this right here is a practice that you kind of pick up as you start doing stuff. I probably started using return as a result after years of programming. Like this just makes sense to me. And sometimes it's just like that. You know what I mean?
Hey, DJ, real
Yeah.
quick it just so happens that on the modules we do A, B, C grade or whatever. And I tried
Mhm.
one, didn't work out, but I didn't try this result thing. So I guess it's another way of doing it then, right?
Well, the result's that's just the placeholder variable. So up here, I've assigned it to an empty string. And I don't really have to put it there, but that's more of a mental note to me that, hey, I want my result variable. I want to return a result variable, and I only want to put one return statement in. And this right here comes down to, I've seen it a lot of people use this method because it's easier to trace where your function exits. Because if you're only looking for one return statement, and then you can work your way backwards from that if you need to. It starts becoming more important as you are starting to debug your function. So that could be one avenue you could look at the function that were you building a function or just a series of ifs?
Series of ifs. There were no functions in there. Just if, greater than 90, A, if greater than 80, 80, B, that sort of thing. And
Hmm.
in the end, it gave me an error or whatever. I'm still trying to figure that one out, but it's in the modules, exactly this exercise.
Okay. If you continue to have issues with it, feel free to
I will. I'll
give
get
a
it to you.
shout out. Yeah.
All right.
But yeah, this right here was also a quick thing about the keep it simple thing. So because we were only looking for a couple of results here, we can go through and we could break out a grading schedule or scale, but do we have all of those examples? Do we have all of the things of what is a B? What is a D?
You
We
can.
we can, but we don't have an example of it here. So I
Would you
just
have to
made,
create it? Like that
yeah.
list, that long list of data?
Oh, no. There's still just a series of if statements. It's ifs, elifs, and whatnot. But I don't have numbers that I want to gauge that on. And this is 96 returns A, but that doesn't tell me is that where A starts or does A start at 90? Do you see what I mean?
Oh yeah.
Yeah. Or if it could be like an A plus, A minus, if you want to break it down even more, or I don't know,
Exactly.
whatever the
Yeah.
result is intended
So
to be.
so that's where I'm saying this is where we're not trying to over engineer it, because we could spend hours. Well, my school grades this way and your school grades that way. And you see where you could spend a lot of time building it out, but we only have two test cases that we're looking for, right? So
Yeah.
to get it to work right now, we satisfy those two test cases, which we just did with an if else, right?
Yep.
Sometimes sometimes it's easy to get carried away and try to break everything out and whatnot. It's good for practice as long as, you don't overdo it. Any questions?
Nope.
That we are now at the conclusion. Um, I know we covered through scope pretty, I don't know, I feel a little haphazard about scope, but do you guys have a bit of a warm and fuzzy, or is it clear as mud?
For me, when I'm looking, when you say scope, I'm thinking about how the structures, and you said how, the indentations of the functions are like the details of the entire program, I guess. That's the way I look at it. I'm not sure if that's right or wrong.
I think the main thing to think about at this stage right now is your variable scope, your variables inside and outside the functions and that stuff. And sometimes it helps drive it home by just practicing with it. Create a variable outside, try to access it inside, try to play with it inside and see what it looks like outside. Um, this example is actually really good if we go through and build it out step by step. And maybe that's a good thing to be able to break this out and put the pieces in step by step so you can see where the pieces are going instead of all of the logic and then all of the output. Um, which reminds me, when you're building out stuff, when you're testing these exercises and everything, you want to run your program often. So, like for the example of doing the stubs, like def my my awesome function, right? And then doing the pass and just placing the placeholders there. And then the reason why you want to run things and run things often is you want to catch things as soon as they don't make sense or as soon as you break something. Because if you just code and code and code, you could be working on trying to the error you could be working on might be a symptom of another error. Does Is that pretty clear? Or I don't have a good example of it offhand, but I could probably come up with a pretty complicated series of errors that would and
I guess
I've
you're
done it myself.
DJ, I guess you're saying to run the program in order to diagnose if you have a problem or not, because you could keep on going with mistakes and not even know it.
Yes. Yeah, you need to see what it's doing. So even when we're adding those, even if you with this fine name, if you were building that out, putting in a print statement to say, "Hey, I made it this far," and then testing it out before you finish out your logic. Like when we were the great example of why this is -1. Well, in this particular instance, what we could do is we could go like I'm going to separate this out because I want to comment this out. So if we weren't sure what we're doing, we could just print name location so we can see where it's at. Okay, my name location is 103. You're kind of at this point, you're ignoring these falses because this right here it's not finished. So um, it may not be the correct answer, but it is doing something else we intended on. It's confirming that we assume it to be false. So we know that the only thing we need to do is only change false if it's a true case. Is that clear? Or I know I kind of explained that a little bit, so please ask questions. I can help clarify that. I know sometimes it is hard to um, figure out what are the questions to ask, but
I think the important part's just getting hands-on and practicing for me anyway,
it
because like especially the trying to find back the excuse me, the errors. Like yeah, I was trying earlier today going over some of the material. I was like, dude, I'm getting error after error after error. And then I'm like, yeah, it's frustrating. But yeah, it's just like for me practicing and just understanding the concepts as I go and
yeah
just reading the course content also because it's good. It just for
try
me it just takes practice.
try to practice that build a little and run it, build a little and run it kind of thing. Even if it is a bigger function like the one Todd was talking about the grading piece, build a little and run it. So like um as we were working with our letter grade, we could easily just build it up to get to, okay, let's just get the result of an A. But see, even at this state right here, we're only building it up a little and running it. So now if we want to start thinking about our other pieces, now all we're doing is just adding to it. But it works best if you're building and running. Does that help clarify or
Yeah, no, 100%. Yeah,
yeah,
Yes,
that's
okay.
absolutely.
And 100% hands-on is always the best way to learn. This isn't something, even if you've got programming books, you need to put your hands in a code editor or something. You need to run the code because, I mean, you can't just read this stuff and have it commit to your memory. There's probably like 1% of people that can, but I'm definitely not one of them.
Me neither. And DJ, with as far as the program that you pointed out, for me, what I'm doing is I'm looking at, do I get the very basics of it? And those
hmm
last three lines on the print name, find Roger, the very basic is, you run that and the print find name, that's the barrel it's looking in, and you're looking for Roger Delgara. And
hmm
and then it's telling you it's there, true. Same thing with the bottom line, true, true. And then so if you print name, Jill Jones and string, it's going to say false. She's not there. That's really the bottom line of what we're trying to do there.
Yeah, yeah. So that's step one is understand what you're looking to do. It's the first part is what is the problem that I'm trying to solve? And 90% of the time, that doesn't have anything to do with typing any code. It has to do with just looking at the problems like, okay, what are we looking for? Which, I simplified it, but that's exactly the approach we took towards this exercise. We have just a couple examples. Yes, we could really build it out and we could probably spend an hour doing it. But in the long run, it's a long series of if else state or if else statements, which is good practice. But after about two or three of them, we kind of get the idea, right?
Yeah.
But when you start looking for other places to use that logic, that's where you start flexing those muscles. So like using your conditionals in the other places that we were using them. well, here's our product and our threshold and whatnot. You're going to see conditionals are used all over the place in programming. And yeah, you can already see that this first exercise is,
Wow.
fixing stuff, it looks like. It looks like you're going to have to fix these if this, see, like what I said, when you start nesting, it starts to get to where it gets pretty difficult to read. So you really have to stop, trace through, and use what works best for you. When I really suggest, I like pen and paper. I like pencil paper and just kind of sketching out the way my ideas are going. But if that doesn't work for you, figure out what does, because we're not all the same. We all think differently. And the most important thing is it's got to make sense to you. Any questions?
No.
All right. I'm going to, I did not cover this on the video yesterday, and I'm still working on that. But whenever we're done in code spaces, make sure you come back to the code spaces tab. And I did post up a couple of screenshots, but I don't know if everybody's seen them. But ensure when you're done with your code space for the day, make sure you should have one, but if you have more than one, look for the one that is marked active, hit the ellipsis, and select stop code spaces. Any questions there?
Yeah, I don't have stop code space. Well, you said select code spaces and then stop code spaces, right?
Yeah, if it's active, you should have the stop code space.
Yeah, I
If
don't
you
have it.
don't see it, refresh the page. Because if you were actively inside, if you were actively able to run code, then you are in the code spaces page, right?
Yeah, I pressed refresh and it doesn't seem to be doing anything. So I'll go back to
Does
code
it?
space.
Yeah, I want you in. It'll say code spaces right up. Oh, right up here.
Yeah, I got code in the upper left-hand corner.
Yep.
I print
And you
refresh.
should have. And you had your parakeet one. Yeah,
Yeah,
was it
it's
turbo
gone.
parakeet?
Yeah, it's there. He's there now. Turbo. I just clicked on him, and now I want to.
Is there an
Now I want
active? Is there a button that says active over on the far right?
to. It's bringing me back, so it's going through the motions.
Oh, so now it
I
is
think
active.
it's. Yeah, it's starting. Yeah, Yeah, I'm there now. It's putting code spaces turbo parakeet. So now, and it just brought me back. So now I will go back and.
Now you should be able to hit that right next to active. There's this ellipsis. 3 dots is the ellipsis.
Well, 3 lines. Let's see.
3 lines is a hamburger menu.
Okay, so the ellipses are the 3 dots. Got the three
Yes.
dots. Got them. And just show open editors. I don't think that's it. Ooh, here it is. Same thing. Show open, close all, save all. Would it be close all?
Are you in the, are you still in the editor? Are you still in this screen?
Let me see where you are. Hold on.
I don't want you in the editor anymore to be able to close it. Unless you're going to, well, I want to show you how to shut down the code spaces because there is a limited amount of time each month. We will get a reset next week. So it's not going to be as crucial, but you do want to know how to do this.
Okay. Yeah.
So where I want you at this code spaces page, the one that says your code spaces.
Yeah, hold on. I just clicked on Turbo Parakeet.
So I don't want you to actually click on Turbo Parakeet
Okay.
because that'll put you in the code space. We're trying to shut it down now.
Yeah, I think I'm away from you again because, like I said, I went to the three ellipses, nothing. I went to the three lines, nothing. This always happens for some reason.
Check for the active right here. Well, I'm okay. I'm going to finish out these instructions and then I can dive in and help you out. All right.
All right, that's fine.
May I
Okay.
help him? Because he's where I'm at.
Oh,
Yeah.
If you,
okay.
so if you see like the back arrow, right? Of course, don't push the back arrow. Like if you're gonna get out of the whole program or you're gonna go back, and you see the icon, the little blue icon.
Yeah, there's one right below it.
Yes. Now the three hamburgers that he's talking about, click that one.
Yeah, I did, and it's coming.
Eh,
It's got file, edit,
yes, but
selection.
it says my code spaces too. So go to my code
Yeah,
spaces.
you're right. Should have found. There it is. You're right.
Oh, that's an alternate way to bring him to his code spaces. Thank you very much, Marianne.
There you
No
go.
problem.
And then now
Yes.
back in
No,
code, but it still doesn't have leave code spaces.
no, all the way over to the right. Do you see the active button? You should, because you have your code space running, one of them should
Hmm.
say have a green dot and say active. And directly to the right of that, you should see the three dots. It should give you some kind of hover, and when you click it, it'll pop a menu up.
Yeah, he has to move his screen down, and it
Yeah.
says owned by your name, and then you go all the way
Yes.
over.
Yeah.
Screens down.
It's going to be near the middle to the bottom of your screen, depending on, but it says owned by your username.
You got to
Yeah, I
scroll
got
down.
that. Yeah, I got that. It says owned by. I got it.
Yes, and then it says active all the way over to the right.
Yes, it does. Got it. And then there's the three ellipses. You're right.
Yep. Should be fourth option from the top. Stop code
Stop
space.
code. There we go.
Yep.
Boom. I got it.
Once you
All
do
right.
that,
Yay!
there we go.
It's victory. Oh my God. Okay.
All right. Is there anybody else having any issues, or are we all good to go? Now, keep in mind if you're done working with the stuff at the end of class, make sure you shut down your code spaces. There are at the end of the lesson 2, there should be 2 exercises. No, there's 5 exercises, but it looks like it's mostly cleaning. Yeah, it's mostly cleaning up the logic to the if else statements. It's working through the through the conditional statements, and then there is an additional lesson 2 exercises under the exercises folder. Go ahead and try to practice it with that stuff because there's other pieces that we have used in there. Be sure to reference the material. Don't try to memorize this. All right. Somebody's got background. And yeah. If anybody needs any help, feel free to shout out into the Intro to Coding channel, send me a message. Then I'll do my best to give you a hand. All right.
Yeah.
I did have a question.
Okay, go ahead.
Let's say that tomorrow I try to start work or I start working on these exercises and I want to go over um all the stuff that we talked about today. Is there like a link or a YouTube video for all the stuff for this specific class that we went through?
This video will be posted tomorrow, and
Okay.
I can also post the playlist for a previous full class iteration if you want to look ahead or see if there was a different way that myself or the previous instructor presented it. That's always handy. Yeah, just let me know what you guys are looking for, and I'll make sure to get you guys the material. All right.
Yeah. Can I get the second one that you talked about, the one for the whole class? with a different instructor also?
Sure.
Thank you, sir.
Yeah, do me a favor and inside Slack, can you send me a DM, a direct message? That way I've got you right on my radar and I can get you the playlists that way. Yes,
Gotcha, will do.
Janae, these playlists are all on the Code Platoon playlist. They're all on Code Platoon's YouTube. They're under they're under dedicated playlists for each month session that they've been done. Okay, any more questions?
Yeah, I'm gonna need, I wasn't supposed to be here tonight, so I'm gonna need the video for next week. This one I'm okay, but next week I'm gonna need the video, so I guess I'll be trying to get a hold of that.
Yeah, we will have that posted. Um, and yes, that'll be posted tomorrow. All right. I'm going
Okay.
to end the recording.